Okay, picture this. It's the early 2010s. Machine learning is officially everywhere. I mean, it's powering the recommendations on your favorite streaming apps, it's being deployed in massive banks, healthcare networks, insurance companies, the whole shebang. But behind the scenes, in the fiercely competitive world of data science competitions, something really strange is happening. A single, mysterious algorithm is just quietly taking the crown, over and over again. People are uncovering what turns out to be one of the greatest engineering achievements in classical machine learning, and it is entirely changing the landscape. So in today's Explainer, we're diving into one fascinating question. How exactly did the single algorithm become the undisputed king of machine learning? Now, you got to remember, at this time, artificial intelligence was riding this massive hype wave, right? Fueled entirely by deep learning and huge neural networks. These massive systems were out there conquering image recognition, natural language processing. They were the stars of the show. So the obvious question is, why wasn't deep learning winning these specific data science competitions? Why were top data scientists suddenly relying on something completely different to predict things like credit defaults or medical diagnosis?
Well, the answer actually lies in the data itself. You see, deep learning absolutely thrives on unstructured data. We're talking pixels in an image or audio waves. But the real business world, that runs on structured data, spreadsheets, huge rows and columns of customer ages, account balances, transaction histories. And structured data, it turned out, required a completely different kind of intelligence. It needed an approach that didn't just smash data through some massive neural net, but rather an algorithm that learned methodically.
Chapter 2. Learning from mistakes.
So to understand how this mystery algorithm conquered all this structured data, we actually have to look at its underlying intuition. And we start with its most basic building block, the humble decision tree. Think of it like a giant flowchart. The algorithm finds the most informative feature, say asking, is the customer older than 30? And it splits the data. It just keeps doing this until it reaches a final prediction at the very ends, which data scientists call the leaves. Now, on its own, a single decision tree is what's known as a weak learner. It's simple, it's fast, sure, but it often makes errors. Honestly, on complex data sets, a single tree is only slightly better than random guessing.
And this is where the real magic happens. What if, instead of throwing away a flawed tree, you could actually learn from it? This is the brilliant concept of boosting. Here's how it works. Step 1, you make predictions with your first tree. Step 2, you highlight the mistakes, the residuals, where that first tree got it wrong. And then step 3, you build a completely new tree, but this time it is focused exclusively on correcting the previous tree's errors. And you just repeat this again and again and again. You're basically building this additive model where every single new tree compensates for the weaknesses of the whole forest. To kind of visualize how this math plays out, take a look at how tree 1 splits data based on, say, age and gender. It assigns a score, let's say +2 for the boy and -1 for the grandpa. But like we said, it's not perfect. So tree 2 is built to refine this, looking at a totally different feature, like whether they use a computer daily. To get your final prediction, you simply combine the scores from both trees. The boy gets a 2 from the first tree and a 0.9 from the second, giving you a highly accurate final score of 2.9. It's just an incredibly elegant, iterative process.
Chapter 3. The secret behind XGBoost.
Now, by combining all these trees using a mathematical technique called gradient descent, we get what's called gradient boosting. But a researcher named Tianqi Chen realized this was extremely computationally expensive on large datasets, so he built a highly optimized version, extreme gradient boosting, or as we know it today, XGBoost. And listen, this isn't just some magical AI black box. It is an absolute masterpiece of brilliant engineering. If you look inside the engine room, it takes those concepts of gradients and residuals, but adds severe regularization to prevent the model from overlearning the training data. It uses mathematically advanced tree pruning to stop the trees from getting too deep. It introduces column sampling to speed up computation and prevent overfitting. And crucially, it introduced parallel processing, meaning multiple trees could be built across your computer's cores all at the exact same time.
Because of those specific engineering optimizations, the performance gains were just staggering. In benchmark tests on certain datasets, XGBoost's sparsity-aware algorithm ran up to 50 times faster than naive implementations of gradient boosting. 50! It wasn't just slightly better, we are talking about a generational leap in computational efficiency.
But, it wasn't even just about raw speed. Real-world data is messy. It's full of missing values, blank cells, zeros, what data scientists call sparse data. And as the original research explicitly noted, XGBoost handles all sparsity patterns in a unified way,
Basically, instead of crashing or forcing you to do massive data cleanup beforehand, XGBoost is engineered to gracefully handle those missing values. It literally learns the default direction a data point should take in the tree when information is just absent.
Chapter 4. Why everyone used it.
So, these engineering marvels obviously didn't just stay in the lab. They translated into total real-world dominance across almost every sector of the economy. Literally, whenever there was a high-stakes business problem involving structured tabular data, XGBoost became the default choice. In finance, it became the go-to for credit risk modeling, predicting exactly who might default on a loan. In insurance, they deployed it for fraud detection. Massive telecom companies used it to predict churn, meaning which customers were likely to cancel their service. And in the medical field, it was successfully aiding an incredibly complex diagnoses.
When you dive into the actual applied research, the sheer power of these capabilities becomes crystal clear. Take real, structured insurance data. Policy states, deductibles, premiums. Researchers applied XGBoost to this data to predict insurance claims and flag fraud with just unbelievable accuracy. And it goes further. Research published in the International Journal for Multidisciplinary Research highlighted how XGBoost completely outperformed traditional individual learners in telecom churn prediction. Why? Explicitly because it handled that noisy, messy customer data better than literally anything else on the market.
And trust me, the data science community took notice. On Kaggle, which is the world's premier platform for machine learning competitions, XGBoost absolutely took the community by storm. By 2015, it was completely dominating the leaderboards. In fact, it was reported that XGBoost was used in over 30% of all Kaggle competition winning solutions. 30%, it was incredibly fast, it was highly accurate, and it was just crushing the competition.
Chapter 5. The Age of AI.
So, let's fast forward to today. We are fully immersed in the era of generative AI, large language models, massive neural networks. You might be wondering, how does XGBoost even survive in a world that is so completely obsessed with deep learning? Well, when you compare them side by side, you realize they aren't actually competing at all. They dominate completely different battlefields. Deep learning is without a doubt the undisputed king of unstructured data, your text, your video, your audio. But it requires massive compute power and colossal datasets to even function. XGBoost, on the other hand, totally rules structured tabular data. It trains incredibly fast, it requires vastly lower compute resources, and most importantly, it offers high interpretability.
And that interpretability, that is absolutely key. Think about it. If a bank uses deep learning to deny your mortgage, that algorithm is basically a black box. Nobody can really explain exactly why it made that specific decision. But because XGBoost is built on decision trees, it offers both local and global interpretability. Data scientists can literally look inside the model and explain exactly which features drove a specific prediction. For heavily regulated industries like finance or healthcare, that isn't just a nice feature to have, it is a strict legal requirement. That is exactly why XGBoost still wins hands down on small datasets, tabular data, and in low compute environments. To sum up this whole dynamic, I think it's best said like this. The AI revolution didn't replace XGBoost. It simply gave it a different battlefield. While these massive neural networks are out there writing poetry and generating crazy images, XGBoost is quietly running in the background, making sure your credit card isn't being used fraudulently and ensuring your hospital has the most accurate medical risk predictions possible.
Ultimately, the core takeaway from the story of XGBoost is that engineering innovation really matters. Algorithm fit matters. The best AI isn't always the biggest model that requires millions of dollars in server costs just to run. Very often, the best AI is simply the right algorithm for the specific problem at hand. XGBoost proved to the world that brilliant optimization can overcome brute force computational scale.
It succeeds by constantly, methodically learning from its own mistakes. It thrives because of a series of brilliant engineering innovations that made it both incredibly fast and stunningly accurate. So as these massive neural networks and AI assistants continue to scale up, taking all the credit and dominating the headlines, we really have to ask ourselves what other highly optimized hidden algorithms are out there right now, quietly running the world. Long before AI assistants changed the world, XGBoost was already changing it, one tree at a time. Thanks for joining me on this explainer. Catch you in the next one.